Okay, greetings. In this lecture, what we'll be seeing is we'll be continuing with your per unit system. Okay, so what is your per unit? I'll be saying. So you have to know about the per unit. What is per unit and what it is used for alone, I'll be briefing out and I will be giving the formula. Okay. So in the power system analysis, okay, so power system analysis is nothing but your power system network, okay, the transmission and distribution network, okay. For electrical engineering, per unit system is a expression of system quantities, okay, as a fraction of a defined base unit, okay, defined base unit, okay. For this example, uh, you might have studied in your chemistry, right? In your chemistry, you might have studied with respect to your Avogadro number, right? Avogadro number. So in that, what you'll be doing is you will be having this Avogadro number as a base quantity. Okay. So with having this Avogadro number as a base quantity, you will be finding the molar quantity, right? So it's generally you might have studied in your higher secondary itself. So with respect to that, similar to this, you here in power system, you'll be having a particular quantity for normalizing. Okay, so this here, this molar will be normalized based upon this Avogadro number. Okay, similarly, if in your power system analysis, for example, your voltage what you are sending will be 415 volt means, okay, source voltage is a 415 voltage means if you are having this as a base unit, okay, for example, from your Thuthukudi power plant, you are sending 415 unit to all the houses at your all the industries at the Tamil Nadu, okay. At that time, this will be taken as a base unit. So based upon this base unit, if there is any voltage drop, okay, means they will be finding the percentage of voltage drop, keeping this as your base quantity. Okay, so the main purpose of this is for calculation simplification. So the calculations are simplified due to this introduction of a per unit. Okay, so this is a formula for your equivalent circuit with uh, impedance refers to your primary. Okay, primary. So this is for your in terms of your per unit. In terms of your per unit, they have given. Okay. So here it is very clear for your primary side. Okay, so this here is your equivalent impedance. So I have already said about your impedance. Okay, so impedance. So that is equivalent impedance into MVA. So MVA corresponds to your apparent power. Okay, divided by the kVB. Okay, so here means kilovolt. So here it's a kilovolt sending in voltage. Okay. Similarly for your secondary side, the only difference is that this Z equivalent value changes between this primary and your secondary. Okay. So this is what with respect to your per unit system.